Hi, I'm Steve Campbell, and I'm here to talk to you about the top 10 unexpected ways I owned you, and finding the things that your vuln scanner failed to find. I was originally supposed to give this presentation at CackalackyCon and BSides Tallahassee this year. However, due to COVID-19, both were canceled. So first, a little bit about me. I'm a senior security consultant and penetration tester at SecureCon. Um, I'm a retired Navy aviation electrician and a Harley-Davidson enthusiast. I say enthusiast because if I was a so-called biker, I would ride in all types of weather and not park the thing for the winter. So I'm not quite there yet. I had kind of a circuitous route getting into InfoSec. I spent 20 years in the Navy. Along the way, I used a reenlistment bonus and bought my first computer, and I got hooked. I also was interested in hacking culture, and there was a couple of times in the Navy I poked around where I shouldn't have and got yelled at, but thankfully nothing ever came of that. So I straightened up, so to speak. So at my last duty station, although I was an aviation electrician, which is where the Twitter handle Alpha Echo came from, I was a system administrator at my last duty station after I checked in and they found that I was going to school at night for a computer science degree and was a computer geek, and they were losing all of their IT personnel and they were going to be down to one civilian contractor. So I was the right person at the right place at the right time. During that last tour of duty, I also found my first 0 day, which was an IDOR, or Insecure Direct Object Reference vulnerability in a DoD website. It basically exposed the PII of hundreds of thousands of Navy and Marine Corps personnel to the internet. And I found it via a printed form. So after the Navy, after retiring from the Navy, I got the OSCP certification. I got into pen testing after spending a few years in IT at age 46. Now, why are we having this conversation? So when I first got into penetration testing and got the OSCP cert, I remember going on the OSCP forums and somebody was asking about, what do you do when every pen test you're given, every scope is something that's been beat up time and time again by vulnerability scanners and other pen testers. And this person was really scared that they were going to be fired or seen as they couldn't hack it, so to speak. And I remember I had the same fears. So when I got my first pen testing job, I remember reading all the reports that I could get my hands on, just trying to learn new methodology and learn how to find the things that scanners will typically not find, which is basically what this talk is about. Along the way, I lost that fear of failure and basically just every day tried to learn something new about methodology and tools so that I could not only find what scanners overlook, but also provide more value to my clients. So the first I'd like to point out is GitHub Secrets. I had this one web application pen test, and the scope was incredibly narrow. It was one host with 2 ports open, ports 80 and 443. And this site was basically a login portal. And if you successfully logged in, it would redirect you to another website, to the main application that was not in scope. And at that point, the only thing I found was TCP timestamps, which is so lame, there's no way I could include that on the report. So anyway, after a while, both automated scanning with Burp Suite Pro and extensive manual testing didn't turn up anything, so I basically circled back to OSINT to dig a little bit deeper. And I found that they had, that their company had a GitHub repository. So I used TruffleHog and to search through all their Git commits and basically found API keys and administrator credentials. And in the end, I ended up getting access as an admin to a website that could control the funds for multiple organizations. Weak egress filtering. So when I first got a job as a consultant, I remember one of the first things I learned on the job was from a guy named Jason Zafuto, who actually helped me get into consulting. There's a good story behind that, because before I started working as a consultant at Rapid7, I was an internal pen tester, never done consulting work before. And Jason Zafuto, I saw a post of his on reddit.com, and he said that he was a senior security consultant at Pentester. And I private messaged him and asked him, I'm a pen tester. How do I get from where I'm at to where you're at? And this guy was great. He reviewed my resume and gave me a hand up, and I appreciate that. But he's the one who taught me about this weak egress filtering. And so basically, one of the main ways I exploit this, and believe it or not, a lot of companies still aren't properly filtering SMB egress traffic, is you can embed an HTML image tag in your email signature if it's an HTML formatted email. And if their firewall is failing to properly screen egress traffic, SMB to the internet, you can capture the target's username and password hash over the internet using something, say for example, like Responder. And Aaron Herndon, the AC3 Lives link here, he created an add-in code for SMB image tag you can find here at the link. But I do want to stress that you should communicate this on the kickoff call with the stakeholder, with your client, because if, say for example, you're performing an external network assessment and phishing is not in scope, if you don't properly communicate this first, this could be construed as a phishing attack. So what I do is on my kickoff calls, I normally tell the client that, hey, I'm going to be testing your firewall egress. I'm going to send you and anyone else on your team that you choose to participate this email with an image tag and check for improper egress filtering. And you'd be surprised how many times I've captured their password hashes and sometimes managed to crack them to gain access on these external assessments. SMTP spoofing and open relays. So I remember doing this external assessment and didn't really find a whole lot, but I started digging around on the SMTP server. And so basically I found weak SPF records. And although the scanner did not detect this, because typically a scanner is going to try to spoof the email domain to see if you can do relaying. Well, in this case, the scanner failed to find this, and I telnetted to this SMTP port and started digging around, and I actually found that I could manually send an email through telnet to SMTP by sending it from and to people on their internal domain. So I basically found their help desk email and also did some scraping on LinkedIn.com to get usernames. And first I communicated with the client and got permission to test this. And I was successfully able to spoof email from any internal domain user to any other user. So imagine that they had multi-factor authentication, for example. Can you imagine how this can be abused? So using this, you could basically do something like, say if you want to log in on their VPN or Citrix portal, but they're using multi-factor authentication, you could spoof an email and tell this employee whose password maybe you had cracked, hey, this is the help desk, we're going to be testing MFA, and if you receive a prompt over the next 5 minutes, just click accept and use this to gain access. Also on internal assessments. I frequently see where companies will have internal SMTP servers that are open relays. And sometimes it's because they don't know how to properly configure receive connectors in Exchange. So they'll just basically whitelist printers and stuff like that and other network devices. So many times they know that this is a vulnerability. It's been detected on past vulnerability scans. However, they tend to underestimate the risk. So what I do to demonstrate risk from this, and it normally gets them to remediate is I communicate with the client and tell them that, hey, I know this isn't a phishing engagement, we're on an internal assessment, but I found this SMTP relay vulnerability. I'm going to send you some test emails. What I don't tell them is I'm going to include an SMB image tag in the email, and I'm going to be relaying or cracking their hashes. And normally when this gets success, it really opens their eyes to the danger of this when I show them how I used it to own their servers. And so very effective attack vector. So before we discuss IP version 6 DHCP and man-in-the-middle attacks, we need to back up for a moment and talk about LLM&R and MBTNS. So pentesters have known about LLM&R and MBTNS poisoning for many, many years. And if you're not aware of that, it's basically how Microsoft Windows hosts, if they do a DNS lookup and it fails to resolve the host name they're looking for, they'll fail through to link local multicast name resolution and net bias name services and broadcast those over the local network. So anybody sitting on that same network segment can poison replies to those requests and say, hey, that host name is at this address. And then when they try to connect, you can say, for example, if it's for WPAD requests from Internet Explorer, you can request authentication and grab password hashes and either crack them or relay them. So anyway, back in 2016, Microsoft issued a patch for this. I believe it was MS16-077. And it basically patched Windows so that Windows would not give up password hashes over LLM&R and MBTNS, only DNS. And that's where this comes in. So as you can see here in the screenshot, and I almost always find this on internal Windows networks, as you can see, DHCP solicits in this packet capture, and those are linked local addresses, and there's no offer. So these things are not configured for IP version 6, but Windows by default will use IP version 6. However, the system administrators or network engineers or whatever have not configured an IP version 6 scope. So Foxit has this blog post explaining how this works. I believe they're also who made this man-in-the-middle 6 tool. But basically the way it works is Windows will actually prefer DNS over IP version 6 to IP version 4. So if you're on the local network and you're able to pull out this man-in-the-middle attack using man-in-the-middle 6, you basically take over as the IP version 6 DNS server. And it only works on the linked local scope, so you're not going to do a denial of service attack on anybody because it doesn't take over as the router, so to speak. And I've used this in the past where I've failed to get hashes through LLM&R and MBTNS to get hashes, relay them, and become domain administrator quite a few times. The Cybermentor, he has this YouTube video that gives a very good explanation in layman's terms. It gives a walkthrough on how to exploit this. Now, Foxit's blog post, one of the things they mentioned for remediation is, if you're not using IP version 6, you can just turn it off. However, you may experience some bad consequences from that because some Windows services will use IP version 6. So you would need to test in your environment. However, what I typically recommend is a defense in depth approach, a layered approach. So for one, I would not allow anybody with an account with elevated privileges to log in locally on the machine. They should be using a secondary, like a Bang account, for example, to perform any elevated functions on the domain and not log in with that account. Also, network segmentation, and Microsoft also recommends privileged access workstations, which are hosts that are segmented and firewalled off from the rest of the network, and only allowing administrator accounts to log in locally on those systems. For dynamic routing protocols, every internal assessment I do starts with a packet capture. And I almost always find either misconfigured or dangerous defaults on being broadcast from these routers. And some examples are OSPF, for example. By default, it's enabled on all interfaces. However, best practice is to disable it on any user interfaces and only allow the routing protocols to broadcast over links to other routers. HSRP, that's hot standby router protocol. So the Cisco default, this is using plain text authentication with a password of Cisco. So this would enable a man-in-the-middle attack because anybody that's able to capture those broadcasts could basically insert themselves in as the primary router. Here in the graphic, it basically shows down at the bottom, it's showing authentication data default with a password of Cisco. I find this quite often on internal pen tests. It is very important that you take a moment and stop, and when you detect this, not just go YOLO and try to exploit this, because you do run the risk of causing a denial of service condition on the network. So definitely communicate the risk, and if your stakeholder or client gives their go-ahead to attempt to exploit it, then you can use a tool like, for example, your Cynia, unless you want to go low level and write your own escapee. Printer default credentials. So many times I've seen pen tests where we've been pen testing the same client who was already pen tested in the past, and this finding for default Xerox printer credentials was on previous reports, and they never bothered to remediate it because they think, hey, it's just a printer, you know, what are they going to do with this? So Daryl Highland, he published some research on multifunction printers, and I think he was the one who first coined the term the passback attack. And so basically, some models of printers, I've definitely seen this on Xerox printers. When you manage to find one that has, still using the default credentials, I believe that's admin and admin, you log in, and if you find that they have an LDAP connection, LDAP is typically a connection to Active Directory. So in the LDAP connection, it has the IP address or host name of the LDAP server, typically the Active Directory domain controller, as well as the port, like if it's 389 for plain text, or secure, I think 689, I believe, I can't remember, for secure. And so what these printers would allow you to do is to edit the IP address or host name of the LDAP server and save the changes without being prompted to re-enter the credentials. So that enables this passback attack where on the attacker system, you can run netcat, for example, and be listening on port 389. In the printer console, you update the LDAP connection to your IP address, and then if they have a test feature in the interface, you can enter any username and click test, and it'll try to connect with those credentials, and you'll receive the password in plain text. So although Daryl Highland basically originally found this, some years later I found that it had never been patched. It was still being exploited, and I didn't know that he had actually reported it in the specific model of Xerox. I found research of his on other printers, so I reported it again and attempted to register a CVE for this, and I guess, you know, a decade later, and they finally listed and issued a CVE for it. And so they have patched. However, you know, who updates their printer firmware? That's not very common. Normally, system administrators only update printer firmware when it's to fix an issue that's affecting users. So I imagine we're still going to be seeing this vulnerability for quite a few more years. I've also found this particular passback vulnerability in other network devices. For example, I found it in a Barracuda device where you could change the LDAP connection to your IP address without being prompted to re-authenticate, basically. And it turns out that this was a vulnerability in the code base of 3 different Barracuda network devices. Oh, and by the way, as many times as I've found this vulnerability on network assessments, there's only been one time that the service account that was being used to connect to Active Directory was not a member of domain administrators. Let that sink in for a moment. Now, to do an LDAP lookup, you don't need anything beyond an unprivileged user account, but I guess some system administrators, being unaware of that, will think that I have to use a domain admin account for everything. And like I said, one time out of all the times I found this was the account not a member of domain admins. Oh, a true story about this. I was once on this assessment. I was performing the internal network assessment, and one of my coworkers was performing the external network pen test. And my coworker found that this particular client had printers exposed to the internet. That's common to see in like universities, for example. They'll share the printers out so they can be used off campus to print into the office. And so this printer that was exposed to the internet, it was a Xerox printer, was using default credentials, and on an external assessment, he gained domain admin credentials from this printer and was able to log in and basically on the network. Credentials and open network shares. So this is another thing that your vulnerability scanners are definitely not going to find. I've done internal network assessments, say for example, this hospital, and this first crapmac exec command, just anonymous share enumerations. I actually found an anonymous share that was open to everyone group. That allowed me unauthenticated to connect to the share, and it had unredacted client PHI, and including like cancer patients scans, and some other examples of credentials and open network shares. Now, most pen testers these days are aware of group policy preference passwords. It's getting more and more rare to actually find these, but I mean, it's still worth it to check because sometimes you'll still find them. Frequently, system administrators will think that that they're good to go and they've remediated because they've unlinked this particular group policy from an OU, so it's no longer in effect. However, when you enumerate for this vulnerability, if it hasn't been completely deleted, you can still gain access to these credentials. Now, although that's getting less and less common to find, I still quite frequently find open NFS shares and using Metasploit and find credentials there. Also, I wonder how many admins do you think believe that shares that end in a $, that since they're hidden, that the users can't find them? So why bother to lock down the permissions? So I've on internal pen tests, I've been able to find like gain access to a low privilege user's credentials. And when enumerating shares, find that these hidden shares, I mean, they're hidden from view. If you're using Explorer, you have to manually type in the address. You basically can't browse for these hidden shares. So anyway, but you can still enumerate them. And since they were presumed to be hidden and they weren't locked down, I was able to find things like unattend.xml files with local administrator credentials, among other things. Also, while it's great that you're using something like KeePass or something like that to secure account credentials, and that you're using LAPS from Microsoft to randomize all of the local administrator passwords in your systems, it doesn't really make you more secure if you've exported these credentials and left a copy in a text file in the same directory. So I've done assessments where I gained access to VDI as a normal user, browsed network file shares, find the IT share, wasn't properly secured, and KeePass database in the same directory, somebody had actually exported all the entries to CSV file. And the same with laps. I've found on assessments where somebody had a scheduled task that every week would run a PowerShell script to dump all the lapse passwords of all of their systems for the local administrator accounts, to dump them to a CSV file. So your vulnerability scanner is never going to find these, and you need to make sure that you're properly securing your information with applying the appropriate file share permissions. So remote code execution in Cisco Smart Install. So as it says here, Smart Install is a plug-and-play configuration and image management feature. I'm not going to read the rest of it to you. You can do that yourself. However, what you need to know is it basically is like a zero-touch configuration. You plug in an enterprise-grade switch in the network, and if you have a Cisco Smart Install server, it will automatically push out a configuration to the device. I've got links here to the paper where it actually describes the vulnerability, and as well as the tool you can use to test and exploit it. And I frequently find this on internal network assessments. For some reason, the client scanners have never picked up on this. I normally find it through a manual nmap port scan. And the vulnerability allows you to download the device configuration without requiring any authentication. And it can allow you to edit and then upload the altered configuration. And on some devices, you can even run commands on the device through Smart Install and do things like if you can do a packet capture, and you can most likely capture something like SIB traffic and capture password hashes from those. What I typically do most often when I find vulnerable systems to Smart Install is when I download the configuration file. I mean, because out of the things you can do with it, just downloading the configuration file and looking for secret zone is probably the least impactful to the network, the least risky. So what I'll normally do is I'll parse those for any plain text passwords or, for example, Cisco Type 7 passwords. When you find Cisco Type 7 passwords, that, I don't even know if you could call it encryption, but it can be reversed in a matter of like a couple of seconds. You can recover any password at Type 7. And there's a tool, if you Google search for type7.py, I think it was Average Security Guy, released a simple Python script that can reverse those. So once you get those passwords, you can use those. For example, I find password reuse is definitely a problem. And I'll find that sometimes that password is reused on other Active Directory service accounts when I'm doing password spraying. So many times I've done 802.11 wireless assessments, and I always ask on the kickoff call, I always ask the client if client-side attacks are in scope. And the reason why is this: many times these wireless assessments turn out to be very boring. I mean, you might find that they're using WPA2 pre-shared key, and that's a finding because you tell them, you should be using WPA Enterprise, and this is why, because, reasons. And a lot of times the clients just laugh it off. They think, oh, you're never going to get anywhere with this because our passphrase for the WPA2 is so long and complex, you're never going to crack it. So I've done assessments where I've actually, I had permission to do client-side attacks, and I found that they had vulnerable wireless peripherals like keyboards and mice that were vulnerable to mousejacking. So I've got listed here the Crazy Radio PA USB dongle, as well as the software you can use to exploit it. And you actually can send keystrokes over the air to these affected devices and run commands. And some things you should know about this is, one, always communicate with the client. Also, if you're in a congested area, it's very hard to tell who owns the systems because all you're seeing is basically the manufacturer, type of device, and the MAC address. There's no domain name information. So if you're in an office building nearby other companies, you may want to rethink testing in production and ask for some of these devices to take back to your hotel room and test away from their network, because otherwise you might be actually mousejacking somebody that's out of scope. Also, some things I learned the hard way when attempting to create an exploit proof of concept of this is when you're sending these keystrokes over the airwaves, less is more. If you have this long sequence of commands that are going to get typed out on the screen through these wireless keystroke injections, try to put them all in a PowerShell script and have a simple PowerShell cradle that downloads and runs the script. Because basically, if you try to send too much information in each command line that gets entered, eventually it's just going to send a string of characters scrolling across the screen, and it's going to go off the rails and not work. And I've actually been watching people from across the room, and when keystrokes start popping up stuff on the screen, open up Internet Explorer and go into the internet and everything to download my PowerShell cradle and run an exploit, it really can freak people out. So if you notice that they're using these vulnerable devices, it is best to ask to borrow some of these devices and take them off site for testing. So about blind cross-site scripting, I don't know how many times I've done web app pen tests and only found typical low-level things, because these websites have been beat up by other pen testers and vulnerability scanners so many times that you're left with very low severity findings like cookie flags and stuff like that. So what I started doing is this one time I was testing a credit union's customer web app, and I found that when I was putting in cross-site scripting payloads, although they would be reflected back to me, the full payload would be reflected back, they weren't firing because they were escaped or whatever in HTML. So at some point I wondered, I wonder if this credit union has any back-end systems that could be processing these cross-site scripting payloads. So I communicated with my client, and I spun up a copy of Beef, the browser exploitation framework, spun it up, connected to the internet, and whitelisted the client's domains. And I did some more cross-site scripting payloads in some of these forums that weren't filtering the input. And I asked my client to go to any back-end systems where he could view my profile and any of my transactions on the banking website. And I actually captured a screenshot of this system administrator's web browser as he was looking in this backend system, because I configured Beef. There's some you can configure Beef to auto run plugins when it gets a new connection. And if you look in this GitHub path here I've got on the screen, I found in the beginning that there was some trial and error to setting up Beef to using TLS. There wasn't a whole lot of examples on the internet how to do it. So I created this Docker file to spin up Beef in a Docker container, automatically using your TLS certificates and your domain name, as well as automatically running some Beef plugins on connection from the victim that will hook them to the root of the domain, so if they browse away from that page, you don't lose them. And it also takes a screenshot of their browser, so you see what they're seeing when they get hooked by your payload. And since then, I've made it a point to run Beef every time I do a web app pen test, and I always communicate with the client and say, hey, is there any backend systems that are processing data from this web application? And there's been a few times where I've caught screenshots and hooked admins this way. So we've made it through the 10. So now what I want to talk about is some things that aren't necessarily vulnerabilities. They're not things that you find, they're things that you find are missing. And I think a lot of lesser experienced pen testers and system administrators tend to overlook these because they're looking for they're looking for positives, for positive vulnerabilities. These are the lack of a feature. So if you're doing an assessment and you're finding that they're the typical internal network, they don't have host-based firewalls enabled, and you're able to port scan everything on the SMB port. They don't have any network segmentation. They're not detecting your scans. And a word about that, by the way. On every assessment that I do, if it's not an actual red team assessment, if it's a penetration test, I communicate with my client and the stakeholders, and I tell them that, hey, although this is not a red team assessment, the goal is not to evade all detection. Of course, I always want to not cause any pain, and I always want to avoid getting caught by antivirus. But overall, if it's a pen test and not a red team assessment, then I remind the client that, I'm not trying to avoid all detection. However, if you detect any of my activities and receive any alerts, please screenshot them and email them to me. And the reason why is because if you find nothing else on your assessment, the lack of host-based firewalls on internal hosts, that's a finding. Lack of network segmentation, that's a finding, et cetera, et cetera. Lack of response to detection of a Kerberos attacks. Those are very difficult to detect. And actually, adsecurity.org has a very good blog post on detecting Kerberos attacks. And to date, I don't think I've had anybody detect, any of my clients detect the Kerberos attack. Lack of detection and response to adding privileged user accounts. At some point in an assessment, if I get domain admin privileges, I'll wait a while. I won't do it at the beginning of the assessment, but later on in the week or whatever, I will add an account, one account to domain administrators and another account to enterprise administrators, and I'll wait to see if they're detected. And if they're not detected, then that's definitely a problem, and that's a finding. I tend to find that most companies these days will detect the addition of a domain admin, but for some reason, they don't bother to look at enterprise admin accounts. Like maybe that's a forgotten group, I don't know. But I seem to detect that it's not detected when you add an enterprise admin much more often than a domain admin. So definitely communicate with the client before, during, and after the assessment and ask for feedback. Ask for notification and screenshots to be emailed to you for any of your activities they detect. And you should definitely be calling out the positives for your client and putting it in the report, if they're doing a good job, if they detected this or that, and you've been caught, good for them. Include it in the report. They'll love you for it. So had this been in person at one of those conferences, I would have opened up for questions, comments, and feedback right now. However, since this is going to be posted on YouTube, I would definitely like any feedback. If you have any tricks or tools that you use that wasn't mentioned here that are frequently overlooked by vulnerability scanners and other pen testers, I would love to hear about them. If you have any other questions or comments or feedback, please reach out to me on Twitter. Thank you.